Hello everyone, hope you are doing well. I'm Reza, founder of the OptimizationCity.com. In this film, we answer this question: what is transportation problem? Let's move on. In this presentation, we focus on a special case of the minimum cost for problem called transportation problem. The transportation problem, which is the main topic of the discourse, is a specific type of minimum cost for problem that does not involve the intermediate points or nodes. So this is the intermediate. So this is not a transportation. This is a transportation because there is no intermediate point. To express the mathematical formulation of the transportation problem, we define the following parameters. R sub I represent the amount of supply available at source I is equal to 1 to M. Bj represent the amount of demand required at the destination J 1 to M. And Cij denote the transportation cost per unit from source I to destination J, which I is equal to 1 to M and J is equal to 1 to M. In the transportation problem, we assume that the total supply here for our resource is equal to total demand for all destination. This ensures that the balanced distribution for the goods and resource. Suppose that Xij represent the quantity of unit transport from source I to source J. In this case, we can formulate the transportation problem as follows. Here we are going to minimize the objective function, which is the transportation cost, and this is the balance equation for resource I, and this is the balance equation for destination J, and this is the non-negative decon. So as you can see that we don't have any capacity for each arc. Let's see an example. A big company producing its product for 3 factories here, factory 1, 2, and 3, and need to transport them to the 4 warehouse here using a truck. Since the transportation costs are significant expense, the company manager aimed to minimize these costs. The table below provides the information about the shipping cost. So you can see that the shipping per unit of transport from 1 to 1, factory 1 to warehouse 1 is 464. And we have the demand and supply. Now, the linear programming model for this problem can be right here. So we have the minimization for the objective function, and this is the balance equation for factory 1, 2, and 3, and this is the balance equation for warehouse 1, 2, 3, 4, and this is the non-negative constraint. Thank you so much for watching me. If you are any question and need any assistance, please do not hesitate to contact us by email or by filling the contact form in our website, which is www.optimizationcity.com. Thank you so much and goodbye for now.